All right, guys, for this video, we're not going to really focus on the graphing, but we are eventually going to graph rational functions. All right, and we'll probably do this later in the week. Write down the goal. So the main thing we want to do on this video is we want to identify asymptotes, intercepts, and symmetry so we can kind of use what we did on the last couple video lessons, and then eventually we'll focus more on graphing the shapes here. All right, the big thing with this is asymptotes. We're going to kind of come up with a conclusion, if not in this video, but probably the beginning of class. We'll come up with a conclusion on how we get the VA and the HA for all of these. And we know how to do intercepts and symmetry. So if we look at the first one, and it looks like the front side and the back side of the notes, there's 6 problems. We're going to take a look at 3 of them, which goes over 3 different types of cases and how it'll affect the horizontal asymptote. All right, so if I were to do the first one, now this is a review. We've graphed this before. I already know this is the boomerang shape. And I'll just go, the VA is whatever value gives you 0 in the bottom. So that's the easiest way to get the VA. The HA was also y equals 0. So when we graph this, it doesn't hit the x and the y-axis. And if I were to graph, remember, if I want to figure out if it's even, odd, or neither, I could plug in 1 and -1. So if I were to plug in 1, I would get 1 over 1, which is 1. If I were to plug in -1, 1 over -1 is -1. These are opposites, so this proves that this is an odd function. Okay, so you have 1, 1 right here, -1, -1, and it's just these boomerang shapes. And you can see how these boomerangs, if you fold them over the origin, they're symmetric to each other. Okay, so I'll circle this. This is odd. Now, what you also see is that these boomerangs, they don't hit the x or the y-axis. So we'll say NA for x-intercept and NA for y-intercept. All right, if you were to plug 0 in for the opposite variable, it wouldn't work out. You wouldn't get anything. Now, I kind of skipped this. This is kind of the main thing. Now, when I talk about degree, like I say n of x, that's just the top, and d of x is the bottom or denominator. N we could say is numerator. Now, this is going to be kind of the clue of how to get the HA. The VA, as I said, is you always set the bottom equal to 0. If we look at the top is just 1. Since there's no x, we say the degree is 0. It's like saying x to the 0, which is really just 1. Now, since the bottom, which we're going to say is d of x, since that's x to the first, the highest exponent there is 1, we're going to say the degree is bottom. Here's kind of the connection here. If the degree is bigger in the bottom, you're always going to get y equals 0 for the HA. All right, and again, we'll do more practice on that. Okay, let's take a look at another case where the degree is not bigger in the bottom. In fact, I'm going to skip down to number 3. Let's go to number 3. Try to make this maybe a little bit bigger. All right, so that's 2x plus 1 over x plus 1. So kind of building off what we said about the degree. So the degree in the top and the bottom are both 1 because it's like saying 2x to the first and x to the first. Now, if I look at VA, well, I just set the bottom equal to 0. So x can't equal -1. That'll make it undefined. So x equals -1 is the VA. Let's put this in here. Here's my vertical dotted line. Now, usually, if it was, during normal time, I would usually have students graph these on their TI Inspire, and they would figure out what the HA is. I'm just going to give this to you. The HA for this is y equals 2. All right, I'm going to put this in here, y equals 2. So y equals 2 is the HA, x equals -1 is the VA. All right. Now, why does it equal 2? Here's kind of our main thing. If these are the same, if you have the same degree in the top and bottom, what it turns out being, this y equals 2, you just divide the leading coefficients. So the leading coefficients is this, 2x, even make it bigger. You have 2x plus 1 over x plus 1. The leading coefficient for the top is 2. The leading coefficient for the bottom is 1, right, because it's 1x. So when I divide these, we wind up getting this. All right. If I were to change this problem to y equals 3x plus 1 over x plus 1, then the HA would be y equals 3. All right. So that's kind of the main thing with this. If we did, let's see here, if we do intercepts, okay, x-intercept, we set y equal to 0, which is really just setting the top equal to 0. So if you set 2x plus 1 equal to 0, you're going to get x to equal negative 1/2. So this is negative 1/2, 0. For the y-intercept, if we put 0 in for all the x's, we're just going to get 1 over 1. So this is 0, 1. So negative 1/2, 0, which is right here, and here, 0, 1. Okay, connected. This is going to be a boomerang. Now, if you were to put one other point, I would probably go to the left of the VA. If I were to plug negative 2 into this, this is where you can plot additional points. Let's see, if you were to plug negative 2 into this, I believe you would get 3. So negative 2, we're up at 3. Now, if I want to check if it's even on or neither, if I plug 2 into this, let's see, if I were to plug 2 into this, I have 2 times 2 is 4. 4 plus 1 is 5. And the bottom of 2 plus 1 is 3. You'd have 2 and then 5/3, which is like here somewhere. So this is neither. There's no symmetry to this. Again, I'm not really focusing on the graph. Our main thing is the asymptotes, the intercepts, and symmetry, if it's even, odd, or neither. Okay, I'm going to go to the next case, which I'm going to skip down to, let's see, I'm going to skip down to the last one, number 6. This is where the degree is going to be bigger in the top, in the numerator. All right, so let's move this down. Let's go to number 6. All right, so number 6, the degree is bigger up top. The degree is 2. And in the bottom, the degree is just 1, right? Because it's x minus 3. Now, here's kind of the connection here. The HA for this, when it's bigger up top, there is no HA. And in fact, a lot of times the HA is going to be replaced by a slant asymptote. But we'll do that tomorrow in class, go over what a slant asymptote is, which hopefully you did that last year. All right. So, okay, so then what happens here, before you might even look and say, oh, the VA is at x equals 3, but something happens here a little bit different. You could factor out the top, the x plus 3, x minus 3. And then you have that x minus 3 in the bottom. These x minus 3's cancel. So this VA is no longer at x equals 3. Will you wind up graphing? This graph is just going to be a line at x plus 3. Right, so if I graph, this is real easy. X plus 3 is my line. My slope is 1, so you go up 1 to the right 1, up 1 to the right 1. Now, what's going to happen, what replaces that VA, and I'll even write here, is a hole. Originally, it looked like the VA was at x equals 3, but now it's going to be replaced by a hole. So if I put 3 into this, let's say there's a hole at 3. If I were to plug 3 into this right here, I would get 3 plus 3, which is 6. So 1, 2, 3. This would be a hole right here at 3, 6. And you would get that graph on your TI Nspire. All right. So kind of main thing here is that if the degree is bigger up top, there's no HA. Okay, and the x-intercept, if we set y equal to 0, you would have 0 equals what, x plus 3. So we're going to wind up getting negative 3. That's the x-intercept. The y-intercept, you would just plug 0 in for x, so you get y equals 0 plus 3. So this would be 0, 3, which is what we have right here. All right. Then if it's even, odd, or neither, here's my quick check. And I'm just using the resulting function, the y equals x plus 3. If I want to see if this is even, odd, or neither, I'm just going to plug in 1 and -1. So let's see, 1 plus 3 is 4. Then when I plug -1 in, -1 plus 3 is 2. So it's not the same, it's not opposite, so this is neither. All right. So again, this is just like a real quick part. I really want you to kind of make this connection with the degree of the top and bottom and how to get the HA. So that's what we'll really focus on tomorrow is the asymptotes, the intercepts, and symmetry.